Chapter 6, Part 2, of an Inquiry into the Human Mind on the Principles of Common Sense. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. An Inquiry into the Human Mind on the Principles of Common Sense by Thomas Reid. Chapter 6, Part 2. Section 8. Some queries concerning visible figure answered. It may be asked, what kind of thing is this visible figure? Is it a sensation or an idea? If it is an idea, from what sensation is it copied? These questions may seem trivial or impertinent to one who does not know that there is a tribunal of inquisition erected by certain modern philosophers, before which everything in nature must answer. The articles of inquisition are few indeed, but very dreadful in their consequences. They are only these: is the prisoner an impression or an idea? If an idea, from what impression copied? Now, if it appears that the prisoner is neither an impression nor an idea copied from some impression, immediately, without being allowed to offer anything in arrest of judgment, he is sentenced to pass out of existence, and to be, in all time to come, an empty unmeaning sound, or the ghost of a departed entity. Before this dreadful tribunal, cause and effect, time and place, matter and spirit, have been tried and cast. How then shall such a poor flimsy form as visible figure stand before it? It must even plead guilty, and confess that it is neither an impression nor an idea. For, alas, it is notorious that it is extended in length and breadth. It may be long or short, broad or narrow, triangular, quadrangular, or circular, and therefore, unless ideas and impressions are extended and figured, it cannot belong to that category. If it should still be asked, to what category of beings does visible figure then belong, I can only in answer give some tokens by which those who are better acquainted with the categories may chance to find its place. It is, as we have said, the position of the several parts of a figured body, with regard to the eye. The different positions of the several parts of the body with regard to the eye, when put together, make a real figure, which is truly extended in length and breadth, and which represents a figure that is extended in length, breadth, and thickness. In like manner, a projection of the sphere is a real figure, and hath length and breadth, but represents the sphere which hath three dimensions. A projection of the sphere, or a perspective view of a palace, is a representative in the very same sense as visible figure is, and wherever they have their lodgings in the categories, this will be found to dwell next door to them. It may farther be asked, whether there be any sensation proper to visible figure, by which is suggested in vision, or by what means it is presented to the mind. This is a question of some importance, in order to our having a distinct notion of the faculty of seeing, and to give all the light to it we can, it is necessary to compare this sense with other senses, and to make some suppositions, by which we may be enabled to distinguish things that are apt to be confounded, although they are totally different. There are three of our senses which give us intelligence of things at a distance: smell, hearing, and sight. In smelling and in hearing we have a sensation or impression upon the mind, which by our constitution we conceive to be a sign of something external. But the position of this external thing, with regard to the organ of sense, is not presented to the mind along with the sensation. When I hear the sound of a coach, I could not, previous to experience, determine whether the sounding body was above or below, to the right hand or to the left, so that the sensation suggests to me some external object as the cause or occasion of it, but it suggests not the position of that object, whether it lies in this direction or in that. The same thing may be said with regard to smelling, but the case is quite different with seeing. When I see an object, the appearance which the colour of it makes may be called the sensation, which suggests to me some external thing as its cause. But it suggests likewise the individual direction and position of this cause with regard to the eye. I know it is precisely in such a direction and in no other. At the same time, I am not conscious of anything that can be called sensation but the sensation of colour. The position of the coloured thing is no sensation, but it is by the laws of my constitution presented to the mind along with the colour without any additional sensation. Let us suppose that the eye were so constituted that the rays coming from any one point of the object were not, as they are in our eyes, collected in one point of the retina, but diffused over the whole. It is evident to those who understand the structure of the eye that such an eye as we have supposed would show the colour of a body as our eyes do, but that it would neither show figure nor position. The operation of such an eye would be precisely similar to that of hearing and smell. It would give no perception of figure or extension, but merely of colour. Nor is the supposition we have made altogether imaginary, for it is nearly the case of most people who have cataracts, whose crystalline, as Mr. Cheselden observes, does not altogether exclude the rays of light, but diffuses them over the retina, so that such persons see things as one does through a glass of broken jelly. They perceive the colour, but nothing of the figure or magnitude of objects. Again, if we should suppose that smell and sound were conveyed in right lines from the object, and that every sensation of hearing and smell suggested the precise direction or position of its object, in this case the operations of hearing and smelling would be similar to that of seeing. We should smell and hear the figure of objects in the same sense as now we see it, and every smell and sound would be associated with some figure in the imagination, as colour is in our present state. We have reason to believe that the rays of light make some impression upon the retina, but we are not conscious of this impression, nor have anatomists or philosophers been able to discover the nature and effects of it, whether it produces a vibration in the nerve, or the motion of some subtle fluid contained in the nerve, or something different from either to which we cannot give a name. Whatever it is, we shall call it the material impression, remembering carefully that it is not an impression upon the mind, but upon the body, and that it is no sensation, nor can resemble sensation, any more than figure or motion can resemble thought. Now, this material impression made upon a particular point of the retina, by the laws of our constitution, suggests two things to the mind, namely, the colour and the position of some external object. No man can give a reason why the same material impression might not have suggested sound or smell, in either of these along with the position of the object. That it should suggest colour and position, and nothing else, we can resolve only into our constitution, or the will of our Maker. And since there is no necessary connection between these two things suggested by this material impression, it might, if it had so pleased our Creator, have suggested one of them without the other. Let us suppose, therefore, since it plainly appears to be possible that our eyes had been so framed as to suggest to us the position of the object without suggesting colour or any other quality. What is the consequence of this supposition? It is evidently this, that the person endued with such an eye would perceive the visible figure of bodies without having any sensation or impression made upon his mind. The figure he perceives is altogether external, and therefore cannot be called an impression upon the mind without the grossest abuse of language. If it should be said that it is impossible to perceive a figure unless there be some impression of it upon the mind, I beg leave not to admit the impossibility of this without some proof, and I can find none. Neither can I conceive what is meant by an impression of figure upon the mind. I can conceive an impression of figure upon wax, or upon any body that is fit to receive it, but an impression of it upon the mind is to me quite unintelligible, and although I form the most distinct conception of the figure, I cannot, upon the strictest examination, find any impression of it upon my mind. If we suppose last of all that the eye hath the power restored of perceiving colour, I apprehend that it will be allowed that now it perceives figure in the very same manner as before, with this difference only, that colour is always joined with it. In answer, therefore, to the question proposed, there seems to be no sensation that is appropriated to visible figure, or whose office it is to suggest it. It seems to be suggested immediately by the material impression upon the organ, of which we are not conscious. And why may not a material impression upon the retina suggest visible figure, as well as the material impression made upon the hand, when we grasp a ball, suggests real figure? In the one case, one and the same material impression suggests both colour and visible figure, and in the other case, one and the same material impression suggests hardness, heat or cold, and real figure all at the same time. We shall conclude this section with another question upon this subject. Since the visible figure of bodies is a real and external object to the eye, as their tangible figure is to the touch, it may be asked whence arises the difficulty of attending to the first, and the facility of attending to the last. It is certain that the first is more frequently presented to the eye, and the last to the touch. The first is as distinct and determinate an object as the last, and seems in its own nature as proper for speculation. Yet so little hath it been attended to, that it never had a name in any language, until Bishop Berkeley gave it that which we have used after his example, to distinguish it from the figure which is the object of touch. The difficulty of attending to the visible figure of bodies, and making it an object of thought, appears so similar to that which we find in attending to our sensations, that both have probably like causes. Nature intended the visible figure as a sign of the tangible figure and situation of bodies, and hath taught us by a kind of instinct to put it always to this use. Hence it happens that the mind passes over it with a rapid motion, to attend to the things signified by it. It is as unnatural to the mind to stop at the visible figure and attend to it, as it is to a spherical body to stop upon an inclined plane. There is an inward principle which constantly carries it forward, and which cannot be overcome but by a contrary force. There are other external things which nature intended for signs, and we find this common to them all, that the mind is disposed to overlook them, and to attend only to the things signified by them. Thus there are certain modifications of the human face, which are natural signs of the present disposition of the mind. Every man understands the meaning of these signs, but not one of 100 ever attended to the signs themselves, or knows anything about them. Hence you may find many an excellent practical physiognomist who knows nothing of the proportions of a face, nor can delineate or describe the expressions of any one passion. An excellent painter or statuary can tell not only what are the proportions of a good face, but what changes every passion makes in it. This, however, is one of the chief mysteries of his art, to the acquisition of which infinite labour and attention, as well as happy genius, are required. But when he puts his art in practice, and happily expresses a passion by its proper signs, everyone understands the meanings of these signs, without art and without reflection. What has been said of painting might easily be applied to all the fine arts. The difficulty in them all consists in knowing and attending to those natural signs whereof every man understands the meaning. We pass from the sign to the thing signified with ease, and by natural impulse, but to go backward from the thing signified to the sign is a work of labour and difficulty. Visible figure, therefore, being intended by nature to be a sign, we pass on immediately to the thing signified, and cannot easily return to give any attention to the sign. Nothing shews more clearly our indisposition to attend to visible figure and visible extension than this, that although mathematical reasoning is no less applicable to them than to tangible figure and extension, yet they have entirely escaped the notice of mathematicians, while that figure and that extension which are objects of touch have been tortured 10,000 ways for 20 centuries, and a very noble system of science has been drawn out of them. Not a single proposition do we find with regard to the figure and extension which are immediate objects of sight. When the geometrician draws a diagram with the most perfect accuracy, when he keeps his eye fixed upon it while he goes through a long process of reasoning, and demonstrates the relations of the several parts of his figure, he does not consider that the visible figure presented to his eye is only the representative of a tangible figure upon which his attention is fixed. He does not consider that these two figures have really different properties, and that what he demonstrates to be true of the one is not true of the other. This, perhaps, will seem so great a paradox even to mathematicians, as to require demonstration before it can be believed. Nor is the demonstration at all difficult, if the reader will have patience to enter but a little into the mathematical consideration of visible figure, which we shall call the geometry of visibles. Section 9. Of the geometry of visibles. In this geometry, the definitions of a point of a line, whether straight or curve, of an angle, whether acute or right or obtuse, and of a circle are the same as in common geometry. The mathematical reader will easily enter into the whole mystery of this geometry if he attends duly to these few evident principles. 1. Supposing the eye placed in the centre of a sphere, every great circle of the sphere will have the same appearance to the eye as if it were a straight line. For the curvature of the circle being turned directly toward the eye is not perceived by it. And for the same reason, any line which is drawn in the plane of a great circle of the sphere, whether it be in reality straight or curve, will appear straight to the eye. 2. Every visible right line will appear to coincide with some great circle of the sphere, and the circumference of that great circle, even when it is produced until it returns unto itself, will appear to be a continuation of the same visible right line, all the parts of it being visible in directum. For the eye, perceiving only the position of objects with regard to itself, and not their distance, will see those points in the same visible place which have the same position with regard to the eye, how different soever their distances from it may be. Now, since a plane passing through the eye, and given a visible right line, will be the plane of some great circle of the sphere, every point of the visible right line will have the same position as some point of the great circle. Therefore they will both have the same visible place, and coincide to the eye, and the whole circumference of the great circle continued, even until it returns into itself, will appear to be a continuation of the same visible right line. Hence it follows, 3. That every visible right line, when it is continued in directum, as far as it may be continued, will be represented by a great circle of a sphere, in whose centre the eye is placed. It follows, 4. That the visible angle comprehended under two visible right lines is equal to the spherical angle comprehended under the two great circles, which are the representative of these visible lines. For since the visible lines appear to coincide with the great circles, the visible angle comprehended under the former must be equal to the visible angle comprehended under the latter. But the visible angle comprehended under the two great circles, when seen from the centre, is of the same magnitude with the spherical angle which they really comprehend, as mathematicians know. Therefore the visible angle made by any two visible lines is equal to the spherical angle made by the two great circles of the sphere, which are their representatives. 5. Hence it is evident that every visible right-lined triangle will coincide in all its parts with some spherical triangle, the sides of the one will appear equal to the sides of the other, and the angles of the one to the angles of the other, each to each, and therefore the whole of the one triangle will appear equal to the whole of the other. In a word, to the eye they will be one and the same, and have the same mathematical properties. The properties, therefore, of visible right-lined triangles are not the same with the properties of plane triangles, but are the same with those of spherical triangles. 6. Every lesser circle of the sphere will appear a circle to the eye, placed, as we have supposed all along, in the centre of the sphere. And on the other hand, every visible circle will appear to coincide with some lesser circle of the sphere. 7. Moreover, the whole surface of the sphere will represent the whole of visible space. For since every visible point coincides with some point of the surface of the sphere, and has the same visible place, it follows that all the parts of the spherical surface, taken together, will represent all possible visible places, that is, the whole visible space. And from this it follows in the last place, 8. That every visible figure will be represented by that part of the surface of the sphere on which it might be projected, the eye being in the centre, and every such visible figure will bear the same ratio to the whole of visible space, as the part of the spherical surface which represents it bears to the whole spherical surface. The mathematical reader, I hope, will enter into these principles with perfect facility, and will as easily perceive that the following propositions with regard to visible figure and space, which we offer only as a specimen, may be mathematically demonstrated from them, and are not less true nor less evident than the propositions of Euclid with regard to tangible figures. Property 1. Every right line being produced will at last return into itself. 2. A right line returning into itself is the longest possible right line, and all other right lines bear a finite ratio to it. 3. A right line returning into itself divides the whole of visible space into two equal parts, which will both be comprehended under this right line. 4. The whole of visible space bears a finite ratio to any part of it. 5. Any two right lines being produced will meet in 2 points, and mutually bisect each other. 6. If two lines be parallel, that is, everywhere equally distant from each other, they cannot both be straight. 7. Any right line being given, a point may be found, which is at the same distance from all the points of the given right line. 8. A circle may be parallel to a right line, that is, may be equally distant from it in all its parts. 9. Right-lined triangles that are similar are also equal. 10. Of every right-lined triangle, the 3 angles taken together are greater than 2 right angles. 11. The angles of a right-lined triangle may all be right angles, or all obtuse angles. 12. Unequal circles are not as the squares of their diameters, nor are their circumferences in the ratio of their diameters. This small specimen of the geometry of visibles is intended to lead the reader to a clear and distinct conception of the figure and extension which is presented to the mind by vision, and to demonstrate the truth of what we have affirmed above, namely, that those figures and that extension which are the immediate objects of sight are not the figures and the extension about which common geometry is employed; that the geometrician, while he looks at his diagram and demonstrates a proposition, hath a figure presented to his eye which is only a sign and representation of a tangible figure, and he gives not the least attention to the first, but attends only to the last; and that these 2 figures have different properties, so that what he demonstrates of the one is not true of the other. It deserves, however, to be remarked that as a small part of a spherical surface differs not sensibly from a plane surface, so a small part of visible extension differs very little from that extension in length and breadth which is the object of touch, And it is likewise to be observed that the human eye is so formed that an object which is seen distinctly, and at one view, can occupy but a small part of visible space, for we never see distinctly what is at a considerable distance from the axis of the eye, and therefore, when we would see a large object at one view, the eye must be at so great a distance that the object occupies but a smaller part of visible space. From these two observations it follows that plane figures which are seen at one view, when their planes are not oblique but direct to the eye, differ little from the visible figures which they present to the eye. The several lines in the tangible figure have very nearly the same proportion to each other as in the visible, and the angles of the one are very nearly, although not strictly and mathematically, equal to those of the other. Although, therefore, we have found many instances of natural signs which have no similitude to the things signified, this is not the case with regard to visible figure. It hath in all cases such a similitude to the thing signified by it, as a plan or profile hath to that which it represents. And in some cases the sign and thing signified have to all sense the same figure and the same proportions. If we could find a being imbued with sight only, without any other external sense, and capable of reflecting and reasoning upon what he sees, the notions and philosophical speculations of such a being might assist us in the difficult task of distinguishing the perceptions which we have purely by sight, and those which derive their origin from other senses. Let us suppose such a being, and conceive as well as we can what notion he would have of visible objects, and what conclusions he would deduce from them. We must not conceive him disposed by his constitution, as we are, to consider the visible appearance as a sign of something else. It is no sign to him, because there is nothing signified by it, and therefore we must suppose him as much disposed to attend to the visible figure and extension of bodies, as we are disposed to attend to their tangible figure and extension. If various figures were presented to his sense, he might without doubt, as they grow familiar, compare them together, and perceive wherein they agree, and wherein they differ. He might perceive visible objects to have length and breadth, but could have no notion of a third dimension, any more than we can have of a fourth. All visible objects would appear to be terminated by lines, straight or curve, and objects terminated by the same visible lines would occupy the same place, and fill the same part of visible space. It would not be possible for him to conceive one object to be behind another, or one to be nearer, another more distant. To us who conceive three dimensions, a line may be conceived straight, or it may be conceived incurvated in one dimension and straight in another, or lastly it may be incurvated in two dimensions. Suppose a line to be drawn upwards and downwards. Its length makes one dimension, which we shall call upwards and downwards. And there are two dimensions remaining, according to which it may be straight or curve. It may be bent to the right or to the left, and if it has no bending either to right or left, it is straight in this dimension. But supposing it straight in this dimension of right and left, there is still another dimension remaining, in which it may be curve, for it may be bent backward or forward. When we conceive a tangible straight line, we exclude curvature in either of these two dimensions. And as what is conceived to be excluded must be conceived, as well as what is conceived to be included, it follows that all the three dimensions enter into our conception of a straight line. Its length in one dimension, its straightness in two other dimensions is included, or curvature in these two dimensions excluded, in the conception of it. The being we have supposed having no conception of more than two dimensions, of which the length of a line is one, cannot possibly conceive it either straight or curve in more than one dimension, so that in his conception of a right line, curvature to the right hand or left is excluded, but curvature backwards or forward cannot be excluded, because he neither hath nor can have any conception of such curvature. Hence we see the reason that a line which is straight to the eye may return into itself, for its being straight to the eye implies only straightness in one dimension, and a line which is straight in one dimension may notwithstanding be curved in another dimension, and so may return into itself. To us who conceive three dimensions, a surface is that which hath length and breadth, excluding thickness, and a surface may be either plane in this third dimension, or may be incurvated, so that the notion of a third dimension enters into our conception of a surface. For it is only by means of this third dimension that we can distinguish surfaces into plane and curved surfaces, and neither one nor the other can be conceived without conceiving a third dimension. The being we have supposed having no conception of a third dimension, his visible figures have length and breadth indeed, but thickness is neither included nor excluded, being a thing of which he has no conception. And therefore visible figures, although they have length and breadth, as surfaces have, yet they are neither plane surfaces nor curved surfaces. For a curved surface implies curvature in a third dimension, and a plane surface implies the want of curvature in a third dimension, and such a being can conceive neither of these, because he has no conception of a third dimension. Moreover, although he hath a distinct conception of the inclination of two lines which make an angle, yet he can neither conceive a plane angle nor a spherical angle. Even his notion of a point is somewhat less determined than ours. In the notion of a point we exclude length, breadth, and thickness. He excludes length and breadth, but cannot either exclude or include thickness, because he has no conception of it. Having thus settled the notions with such a being as we have supposed might form of mathematical points, lines, angles, and figures, it is easy to see that by comparing these together, and reasoning about them, he might discover their relations, and form geometrical conclusions built upon self-evident principles. He might likewise, without doubt, have the same notion of numbers as we have, and form a system of arithmetic. It is not material to say in what order he might proceed in such discoveries, or how much time and pains he might employ about them, but what such a being by reason and ingenuity, without any materials of sensation but those of sight only, might discover. As it is more difficult to attend to a detail of possibilities than of facts, even of slender authority, I shall beg leave to give an extract from the travels of Johannes Rudolphus Epigraphus, a Rosicrucian philosopher, who having by deep study of the occult sciences acquired the art of transporting himself to various sublunary regions, and of conversing with various orders of intelligences in the course of his adventures, became acquainted with an order of beings exactly such as I have supposed. How they communicate their sentiments to one another, and by what means he became acquainted with their language, and was initiated into their philosophy, as well as many other particulars which might have gratified the curiosity of his readers, and perhaps added credibility to his relation, he hath not thought fit to inform us, these being matters proper for adepts only to know. His account of their philosophy is as follows. The Idomeneans, saith he, are many of them very ingenious, and much given to contemplation. In arithmetic, geometry, metaphysics, and physics, they have most elaborate systems. In the two latter, indeed, they have had many disputes carried on with great subtlety, and are divided into various sects. Yet in the two former there hath been no less unanimity than among the human species. Their principles relating to numbers and arithmetic, making allowance for their notation, differ in nothing from ours, but their geometry differs very considerably. As our author's account of the geometry of the Idomeneans agrees in everything with the geometry of visibles, of which we have already given a specimen, we shall pass over it. He goes on thus. Colour, extension, and figure are conceived to be the essential properties of body. A very considerable sect maintains that colour is the essence of body. If there had been no colour, say they, there had been no perception or sensation. Colour is all that we perceive or can conceive that is peculiar to body, extension and figure being modes common to body and to empty space. And if we should suppose a body to be annihilated, colour is the only thing in it that can be annihilated, for its place and consequently the figure and extension of that place must remain and cannot be imagined not to exist. These philosophers hold space to be the place of all bodies immovable and indestructible without figure, and similar in all its parts, incapable of increase or diminution, yet not unmeasurable. For every the least part of space bears a finite ratio to the whole. So that with them the whole extent of space is the common and natural measure of every thing that hath length and breadth, and the magnitude of every body and of every figure is expressed by its being such a part of the universe. In like manner, the common and natural measure of length is an infinite right line, which hath been before observed, returns into itself and hath no limits, but bears a finite ratio to every other line. As to their natural philosophy, it is now acknowledged by the wisest of them to have been for many ages in a very low state. The philosophers observing that one body can differ from another only in colour, figure, or magnitude, it was taken for granted that all their particular qualities must arise from the various combinations of these their essential attributes. And therefore it was looked upon as the end of natural philosophy to shew how the various combinations of these three qualities in different bodies produced all the phenomena of nature. It were endless to enumerate the various systems that were invented with this view, and the disputes that were carried on for ages, the followers of every system exposing the weak sides of other systems, and palliating those of their own with great art. At last some free and facetious spirits, wearied with external disputation and the labour of patching and propping weak systems, began to complain of the subtlety of nature, of the infinite changes that bodies undergo in figure, colour, and magnitude, and of the difficulty of accounting for these appearances, making this a pretence for giving up all inquiries into the causes of things as vain and fruitless. These wits had ample matter of mirth and ridicule in the systems of philosophers, and finding it an easier task to pull down than to build or support, and that every sect furnished them with arms and auxiliaries to destroy another, they began to spread mightily, and went on with great success. Thus philosophy gave way to scepticism and irony, and those systems which had been the work of ages and the admiration of the learned, became the jest of the vulgar, for even the vulgar readily took part in the triumph over a kind of learning which they had long suspected because it produced nothing but wrangling and altercation. The wits, having now acquired great reputation, and being flushed with success, began to think the triumph incomplete, until every pretence to knowledge was overturned, and accordingly began their attacks upon arithmetic, geometry, and even upon the common notions of untaught Idomeneans. So difficult it hath always been, says our author, for great conquerors to know where to stop. In the meantime, natural philosophy began to arise from its ashes, under the direction of a person of great genius, who is looked upon as having had something in him above Idomenean nature. He observed that the Idomenean faculties were certainly intended for contemplation, and that the works of nature were a nobler subject to exercise them upon than the follies of systems or the errors of the learned, and being sensible of the difficulty of finding out the causes of natural things, he proposed by accurate observation of the phenomena of nature to find out the rules according to which they happen, without inquiring into the causes of those rules. In this he made considerable progress himself, and planned out much work for his followers, who call themselves inductive philosophers. The skeptics look with envy upon this rising sect, as eclipsing their reputation, and threatening to limit their empire. But they are at a loss on what hand to attack it. The vulgar begin with reverence to it, as producing useful discoveries. Is it to be observed that every Idomenean firmly believes that two or more bodies may exist in the same place? For this they have the testimony of sense, and they can no more doubt of it than they can doubt whether they have any perception at all. They often see two bodies meet and coincide in the same place, and separate again, without having undergone any change in their sensible qualities by this penetration. When two bodies meet and occupy the same place, commonly one only appears in that place, and the other disappears. That which continues to appear is said to overcome the other to be overcome. To this quality of bodies they gave a name which our author tells us hath no word, answering to it in any human language, and therefore after making a long apology, which I omit, he begs leave to call it the overcoming quality of bodies. He assures us that "the speculations which hath been raised about this single quality of bodies, and the hypotheses contrived to account for it, were sufficient to fill many volumes. Nor have there been fewer hypotheses invented by their philosophers to account for the changes of magnitude and figure, which in most bodies that move, they perceive to be in a continual fluctuation. The founder of the inductive sect, believing it to be above the reach of Idomenean faculties to discover the real causes of these phenomena, applied himself to find from observation by what laws they are connected together, and discovered many mathematical ratios and relations concerning the motions, magnitudes, figures, and overcoming quality of bodies, which constant experience confirms. But the opposers of this sect choose rather to content themselves with feigned causes of these phenomena, than to acknowledge the real laws whereby they are governed, which humble their pride by being confessedly unaccountable. Thus far Johannes Rudolphus Enopographus, whether this Enopographus be the same who is recorded among the Greek alchemistical writers not yet published by Borrichius Fabricius, and others, I do not pretend to determine. The identity of their name, and the similitude of their studies, although no slight arguments, yet are not absolutely conclusive. Nor will I take upon me to judge of the narrative of this learned traveller by the external marks of his credibility. I shall confine myself to those which the critics call internal. It would even be of small importance to inquire whether the Idomeneans have a real or only an ideal existence, since this is disputed among the learned with regard to things with which we are more nearly connected. The important question is, whether the account above given is a just account of their geometry and philosophy. We have all the faculties which they have, with the addition of others which they have not. We may, therefore, form some judgment of their philosophy and geometry by separating from all others the perceptions we have by sight and reasoning upon them. As far as I am able to judge in this way, after a careful examination, their geometry must be such as Enopographus hath described. Nor does his account of their philosophy appear to contain any evident marks of imposture, although here, no doubt, proper allowance is to be made for liberties which travellers take, as well as for involuntary mistakes which they are apt to fall into. Section 10. Of the parallel motion of the eyes. Having explained as distinctly as we can visible figure, and shown its connection with the things signified by it, it will be proper next to consider some phenomena of the eyes and of vision which have commonly been referred to custom, to anatomical or to mechanical causes, but which, as I conceive, must be resolved into original powers and principles of the human mind, and therefore belong properly to the subject of this inquiry. The first is the parallel motion of the eyes, by which when one eye is turned to the right or to the left, upwards or downwards, or straight forwards, the other always goes along with it in the same direction. We see plainly when both eyes are open, that they are always turned the same way, as if both were acted upon by the same motive force, and if one eye is shut and the hand laid upon it, while the other turns various ways, we feel that the eye that is shut turns at the same time, and that whether we will or not. What makes this phenomenon surprising is that it is acknowledged by all anatomists that the muscles which move the two eyes, and the nerves which serve these muscles are entirely distinct and unconnected. It would be thought very surprising and unaccountable to see a man who from his birth never moved one arm without moving the other precisely in the same manner, so as to keep them always parallel. Yet it would not be more difficult to find the physical cause of such motion of the arms, than it is to find the cause of the parallel motion of the eyes, which is perfectly similar. The only cause that hath been assigned of this parallel motion of the eyes is custom. We find by experience, it is said, when we begin to look at objects, that in order to have distinct vision, it is necessary to turn both eyes the same way. Therefore we soon acquire the habit of doing it constantly, and by degrees lose the power of doing it otherwise. This account of the matter seems to be insufficient, because habits are not got at once. It takes time to acquire and to confirm them, and if this motion of the eyes were got by habit, we should see children, when they are born, turn their eyes different ways, and move one without the other, as they do their hands or legs. I know some have affirmed that they are apt to do so, but I have never found it true from my own observation, although I have taken pains to make observations of this kind, and have had good opportunities. I have likewise consulted experienced midwives, mothers, and nurses, and found them agree that they had never observed distortions of this kind in the eyes of children, but when they had reason to suspect convulsions or some preternatural cause. It seems therefore to be extremely probable that previous to custom there is something in the constitution of natural instinct which directs us to move both eyes always the same way. We know not how the mind acts upon the body, nor by what power the muscles are contracted and relaxed, but we see that in some of the voluntary, as well as in some of the involuntary motions, this power is so directed that many muscles which have no material tie or connection act in concert, each of them being taught to play its part in exact time and measure. Nor doth a company of expert players in a theatrical performance, or of excellent musicians in a concert, or of good dancers in a country dance, with more regularity and order conspire and contribute their several parts to produce one uniform effect, than a number of muscles do in many of the animal functions, and in many voluntary actions. Yet we see such actions no less skilfully and regularly performed in children, and in those who know not that they have such muscles, than in the most skilful anatomist and physiologist. Who taught all the muscles that are concerned in sucking, in swallowing our food, in breathing, and in the several natural expulsions, to act their part in such regular order and exact measure? It was not custom, surely. It was that same powerful and wise being who made the fabric of the human body, and fixed the laws by which the mind operates upon every part of it, so that they may answer the purposes intended by them. And when we see in so many other instances a system of unconnected muscles conspiring so wonderfully in their several functions, without the aid of habit, it needs not be thought strange that the muscles of the eye should without this aid conspire to give that direction to the eyes, without which they could not answer their end. We see like conspiring action in the muscles which contract the pupils of the two eyes, and in those muscles, whatever they be, by which the conformation of the eyes is varied according to the distance of objects. It ought, however, be observed that although it appears to be by natural instinct that both eyes are always turned the same way, there is still some latitude left for custom. What we have said of the parallel motion of the eyes is not to be understood so strictly as if nature directed us to keep their axes always precisely and mathematically parallel to each other. Indeed, although they are always nearly parallel, they hardly ever are exactly so. When we look at an object, the axes of the eyes meet in that object, and therefore make an angle which is always small, but will be greater or less according as the object is nearer or more remote. Nature hath very wisely left us the power of varying the parallelism of our eyes a little, so that we can direct them to the same point, whether remote or near. This no doubt is learned by custom, and accordingly we see that it is a long time before children get this habit in perfection. This power of varying the parallelism of the eyes is naturally no more than is sufficient for the purpose intended by it, but by much practice and straining it may be increased. Accordingly, we see that some have acquired the power of distorting their eyes into unnatural directions, as others have acquired the power of distorting their bodies into unnatural postures. Those who have lost the sight of an eye commonly lose what they had got by custom in the direction of their eyes, but retain what they had by nature. That is, although their eyes turn and move always together, yet when they look upon an object, the blind eye will often have a very small deviation from it, which is not perceived by a slight observer, but may be discerned by one accustomed to make exact observation in these matters. End of Chapter 6, Part 2. Recording by Stephen Reynolds, Durham, Connecticut.